Good evening, world. Welcome to your Thursday evening stroll around your celestial neighborhood. I'm Irene Pease, your friendly neighborhood astronomer, coming to you out of Brooklyn, and just going to give us a little tour around our great big celestial neighborhood this evening. If you like the visuals, I'll be using Stellarium, and a little bit we'll be switching over to that. And right now in the background, you see open space. So you can find those at their respective websites, openspaceproject.com and stellarium.org. So tonight, because I knew how this week was going to go for me, I'm just going to kind of make stuff up as we go along and check out Uranus because 2020, y'all. So, as usual, we like to start off with a little bit of a view of the night sky as seen from Earth. So let's get started with that, and then we can take a little bit of a closer look at, we'll call it Planet 7. So pop on over to Stellarium, see what's happening in the night sky, and oh look, there's the star. So this is looking at now, so about 8 o'clock from New York City, Brooklyn in particular. You might say, wow, is there a blackout in Brooklyn? No, not yet. So this is a little bit fake. I can go ahead and adjust the light pollution. That's a fun thing that I can do with Stellarium. So I can say, you know what? It's never actually this dark here. So let's crank up the light pollution and make this a little more Brooklyn-y. Yeah, there we go. So that looks like a nice clear night in Brooklyn like we had last night. It was gorgeous. So we have lots of planets out, right? So we have Jupiter and Saturn. You should be used to seeing those. They're still up there, and since the sun is setting kind of earlier in the day, you can see them, well, I guess earlier in the day. So we have this thing in this part of the world called daylight savings, and it finally ended. I like to call it daylight shifting, and I usually like to complain a lot about it, but last week I had a guest on, and so I refrained from complaining. So I'm just going to complain this week about daylight shifting and how it doesn't really save anything. And if you really don't like where you are in a time zone, then move further east. But or sorry, you can move further west. So we're pretty far east in our time zone. So things just, astronomically happen earlier. It is what it is, folks. So Jupiter and Saturn, gorgeous, really great. Check them out if you haven't been looking at those. I don't know what you've been looking at. maybe your news feed, but Jupiter and Saturn are out there. Mars is also still really gorgeous out there. You might be able to still see some cool features on Mars because it's been really close, a lot closer than it's going to be for quite some time. And as we get later into the night, we have Uranus coming up also. So I'll go ahead and fake the skies again so we don't actually have to see these beautiful, gorgeous rolling hills of Brooklyn. We can take us to a slightly artificially darker location and see where Uranus is in the sky. So again, Uranus was just past opposition. So one of the closer points to us in its kind of its year as it goes around the sun, really closer in our year. So we go through an opposition with Uranus every year. That happens a lot more frequently than Uranus makes it around the sun. But still a good time to look for it. So it's well positioned. It's just a teensy bit brighter. It doesn't really get that much brighter and fainter because it's so far away. But it is up in the constellation Aries, which is supposed to be a ram, but it looks like this little hook. All right. So if you're out and about enjoying the cool, crisp autumn later in the evening, you will be seeing some other fun things up there. So you can see the Pleiades starting to rise. If you look towards the east, this is set for now. So even if you go outside at, say, 9, 10 o'clock at night, the moon will be rising, but higher in the east, you'll have a gorgeous cluster of the Pleiades. So I kind of wanted to talk about stars tonight, but then I was like, planetary. So go ahead and check this out. If you haven't seen it yet this year, it's going to be coming up through the fall, through the winter. A really beautiful collection of stars you can see with the naked eye, even from Brooklyn, and really gorgeous in binoculars. With a telescope, it's kind of like too much for it because you're not actually seeing the whole cluster, but it's just a nice group of young stars kind of hanging out up there on the back of Taurus, the bull. So those are some fun things to look for this coming week. Also, if you have a solar telescope, go ahead and check out the sun during the day. Make sure you use a proper filter. There are actually some sunspots. We haven't had a whole lot in the way of sunspots. We don't have a lot of daytime, but if we watch, you can either get up, relatively early in the morning, not super, super early, but if we just kind of scroll through to our daytime sky, and we can even maybe zoom in on the moon. Usually stellarium has some kind of fake sunspots on there for us, but there are actually sunspots on the moon. Sunspots on the sun, never on the moon, but on the sun these days. So something exciting to check out, right? It hasn't been super active for the last, few years, and all through the summer, there's been almost nothing, which is fine. So some nice big magnetic storms happening there. So the sunspots are actually slightly cooler regions of the sun. So they're still very, very bright, but they just look not quite as bright against the background of the very, very bright sun. So again, if you're going to do some solar viewing, those will show up in a small telescope if you have a proper filter. Never ever look through a telescope that's not properly filtered to view the sun. Never look directly at the sun with your eyeballs. Sunglasses are not proper shielding, etc., etc. Yeah, so if you're not sure about how to look at the sun safely, go to a good website like, NASA or something. They'll tell you a gazillion ways you can safely look at the sun. But yeah, if you do have good equipment to view it, now's the time to do that. Not right now, but when the sun comes up in the morning. So good times. So that's something fun that you can check out from all these gorgeous mountains of Brooklyn. And yeah, that's your sky for the week. So check out the planets, check out the Pleiades, check out the sun if you have a proper telescope. Go climb a mountain, get some fresh air, be outdoors. So we're actually going to come back to stellarium in a little while, but for now, I want to move on to Uranus. I'm ready to kind of get away from the Earth here. So again, this is open space. So this is kind of software that we can use to fly around the universe in 3 dimensions. It's one of my favorite things to do in all my spare time when I just, want to get away. And all real data, right? So we're basically visualizing the universe as it would appear if we were like out in space or something. So the stars and everything are in the correct positions. We're not actually just making up extra stars. In fact, there in the background, you can see the Pleiades cluster that I was just looking at, right? So there's a Pleiades cluster in there that we just saw in stellarium. But tonight's all about Uranus. So Uranus, high in the night sky. I think I'm going to zoom out a little bit. I want to say it's this one. So we have the apparent orbits of the planets here. And I think we just aim for Uranus. Yep, that's it. So Uranus, again, you can see in the night sky from Earth, but it's the first planet out that that you really need a telescope to see. Unless you really know where you're looking, you're not going to see Uranus just, kind of perusing around the sky, randomly aiming your telescope helter-skelter. Although that's actually kind of how it was discovered. So back in the late 1700s, William Herschel was out observing, pointing his telescope helter-skelter, and he found Uranus. And he was pretty excited, I guess. Who wouldn't be? So it was the first planet to really be discovered. The other planets, so Mercury, Venus, Mars, Jupiter, Saturn, people have known about for thousands of years because you can see them in the night sky, like we were just looking at in Stellarium. But Uranus, not so bright. It's a little further out there. It's a bit smaller than the other giant planets. So Jupiter and Saturn show up really well in our sky because they're so big and they're closer. Uranus is a little bit smaller and it's further away. So it doesn't show up so bright, doesn't reflect as much sunlight, and that light has to travel a lot further to get back to us. So way out here in the outer reaches of the solar system, William Herschel found another planet. And then, of course, there's the big question, what do you call it? Right? You got to name stuff. So Herschel apparently wanted to name it after King George, which everyone loved, except for, well, everyone outside of England was like, yeah, maybe not so much. But so they didn't go with King George. They went with, another like Greco-Roman god. So Uranus or Uranus. They did, however, have the naming scheme for Uranus's moons. So all of Uranus's moons are named after characters from William Shakespeare and Alexander Pope works. So they kind of got like some kind of British artist names in with the moons, all of the moons that have been found. So 27 moons whizzing and whirling around Uranus, all with those fun names. Titania, the largest, so that's kind of appropriate. The one I always remember is Miranda, just because of Firefly, because I feel like when you whisper it, it just sounds really creepy, like, Miranda. So we'll look at some of those moons. If you've been following along, the Amateur Astronomers Association has kind of a series they've been doing there called Moontopia. So at some point we'll be looking probably at Miranda and Titania, maybe some of the other cool moons of Uranus. So Uranus, as you may have noticed, it's a little bit different. So we see the orbits of the moons here are not really lined up with the orbits, with the plane of the solar system. So the plane of the solar system kind of horizontal from our view here, but then Uranus's moons are orbiting around it in the same plane at which that Uranus is kind of rotating in, and it's almost perpendicular to the plane of the solar system. So that's the first kind of super fun, kind of odd thing about Uranus, that it's tilted so much on its side. So it's kind of rolling around the solar system, except that it's not. Its poles are always pointed in the same direction, so it doesn't like roll around like a wheel. But it is on its side, more or less. And it's actually just past being tilted exactly on its side. So it's technically its north pole is pointed slightly below the plane of the solar system, below the ecliptic. So Uranus is actually a retrograde planet like Venus. So we say Venus spins backwards. Venus is the other kind of odd planet like that. And Uranus does as well. So the pole that we're seeing here, so we're coming in on one of the poles. I believe this should be the southern pole, because Uranus is just past, or not just past, it's kind of between seasons. So it's like halfway through autumn. So it'd be like a cross quarter or something, kind of like the cross quarter that we just had. So kind of between autumn and its winter solstice this year. So Uranus takes quite a while to go around the sun. Takes, I looked it up, 84 years. Yeah, so if you're less than 84 years old, yeah, you're less than 1 year Uranian Earth year, or Uranian year. So yeah, it takes a while. So eventually we'll get there. But so then the seasons are a few decades long each, so about 21-year seasons. Uranus has a fairly circular orbit. It's less eccentric than Earth, so it's always about the same distance from the sun. So all the planets are slightly eccentric, so they're at some point in their orbit, they're slightly closer to the sun, at some point slightly further away. Uranus, not as much as Earth, so it's pretty steady on there. So we're coming in on a pole here, and I wanted to kind of just follow Uranus around the sun for at least part of its year and just see what you would actually look at in the sky if you could land there, which we're going to kind of pretend land. So there's no land to land on. It's not really a solid. It's one of the it's not a gas giant like Jupiter and Saturn, but it's an ice giant. So Uranus and Neptune we consider ice giants. In addition to having mostly hydrogen and helium, they have more ices in their atmosphere. So when astronomers talk about ices, that's not just water ice. It does include some water ice, but also methane, ammonia. Um, so those are giving it a little bit more of like the blue-green hue. So it's kind of a sister planet to Neptune, Neptune being a little bit further out. Neptune is a little smaller, but more massive. So I think of Uranus as being like fluffy. So it has about 75% the density of Neptune, which is otherwise pretty similar to Neptune, just fluffier. So that's fluffy Neptune. If you want to call it fluffy Neptune, you can have that. Go ahead. It does have a magnetic field. So most of the planets have some kind of magnetic field. It has a reasonably strong magnetic field, but it's misaligned from its axis of rotation, which isn't a huge shocker. So like even the Earth's magnetic field is not exactly aligned with its axis of rotation. So if you have a magnetic compass, it's not necessarily going to point towards the North Pole. It'll point towards the magnetic north, not the geographic north. So you always need to kind of keep that in mind when you're walking around out in the woods with a compass. That's why you use the North Star instead of a compass, if you can see the North Star. So a lot of the planets don't necessarily have their poles aligned with their axis of rotation. They're usually off by a little bit. Uranus is off by maybe more than a little bit, more like 60 degrees. So it's more off than on, I guess. And it's also completely off center. So that's a little weird. Like most of them, they're not exactly aligned along the same axis, but they're at least centered along the center of mass. But Uranus is just, all kinds of nope, not going to conform to that. So I don't know if you want to think about an oddball or a rebel or just kind of an interesting world out there. It does have some features in the clouds, so we can see these bright features kind of pop up now and then. We don't have super amazing images of Uranus because we haven't really visited it. The only probe to visit Uranus was Voyager 2, and that was like way back in 1986 when it was like a totally different season. So that was basically summer. Back when it was summer in Uranus's northern hemisphere. So this is the southern hemisphere that we've been looking at for Uranus. And if we turn around, we can see, oh look, here's the northern hemisphere where it's dark because we're getting close to the winter solstice for the northern hemisphere. So northern hemisphere on Uranus. There you go. Pretty nifty. Kind of dark these days, and it will be for the next 20 years or so. The other really cool thing before we kind of visit Uranus and take a little bit of a closer look that you need to know is that it does have rings. So most people are like all wild crazy, like Saturn, it's the jewel of the solar system. It has these gorgeous rings. Yeah, well, so does Uranus. Uranus has the second most extensive ring system of the planets. So all the giants, Jupiter, Saturn, Uranus, and Neptune, all have rings. Just Saturns are the brightest and the prettiest. But Uranus's are the second brightest and second prettiest. And along with its moons, it kind of makes it look like a giant bullseye. Okay, so it's like target. It's just asking for it. Okay, so that's a bit of Uranus. So why don't we go ahead and maybe take a little bit of a visit. I'm just going to set up some systems in Stellarium because we can. And while I'm at it, we'll just go ahead and view that part. So fun facts, with Stellarium, you can actually view First, I'm going to change our landscape. So we want to have this look like Uranus and not Brooklyn. Yeah, that looks a lot less like Brooklyn. And you can actually pick locations off-world. So pick your planet or world, as we like to call them. So way down towards the bottom, there's our planet. And right now, I want to be in the southern hemisphere. And I want to check out, see what it would look like. I think this is right. Nope, that's the north. They're saying this is north. All right, fine. If we could see kind of full sky, there's our sky, and kind of just see what it looks like as we go through a few days. So a day on Uranus, so this is kind of like the 2020 thing. It's like the days are short, but the years are long. So the days are only 17 hours long. So if we zip through time, whoa, there, there goes the sun. So it just kind of like circles around and around and around. And it does this like all through what would be the summer, day in, day out for quite some time. If we picked a point that was at a slightly different location, so that would be like with that pole basically facing the sun. If we flip through a few years, we can wait for the sun. Oh goodness. To set. Eventually, we should get to the point where the sun kind of more skims the horizon and just makes like that big circle. A few years later, it should actually set. So we'll have a few years, a few Earth years of like kind of perpetual twilight. So if you want to do like solar astronomy, don't go to Uranus. All right. Yeah. So it's daytime for quite a while, but actually the sun wouldn't be quite this bright during the day. If we just kind of pop back over to open space for a minute and we kind of look around at where is the sun, like from out here in this part of the solar system, as we look back towards the sun, it's like this faint dot. It's starting to almost not really blend in with the background stars. It would actually, be relatively bright, but it's not going to be like bright. We wouldn't have daylight on Uranus and Neptune like the way we have it on Earth. So if I just turn off the planet lines, you can see the sun. That's still the sun, right? That's our sun. It's, reflecting light off of Uranus. It's definitely reaching it. But the sun isn't too much brighter than like some of these other stars, right? So it's way out there. Way out there. So the this kind of view that we get in stellarium, this is a little bit exaggerated, but that's, we're kind of modeling what the day would be like. So it would be like this, but a lot darker. So if we go forward a few more years, then we just have perpetual night for a whole season if we're this close. Oh, so that's nice. If you want to do night sky observing, yeah, go to Uranus. It's just really freezing cold. Like there are parts of Uranus that are even colder than Neptune. So even though Neptune is further from the sun, there are parts of Uranus that are colder. It's kind of like it's kind of like on Mercury. Like there are parts of like Venus. There's parts of like Venus that are actually hotter than Mercury. Most of Venus is actually hotter than Mercury, even though on the day side of Mercury, it's really, really hot because it's so close to the sun. So you have kind of like a flipped effect with Uranus and Neptune. So I feel like Uranus is like kind of like Venus, and then it's like kind of this oddball, and it's retrograde, and it's trying to be like, the planet version of 2020. But but yeah, I would love to get, as Fi's little thank you, I would love to get an analemma for this. So that's a project that I have on my list of things to do. I think there actually exists some online, but if I make one, I'll definitely post that on the YouTube. So kind of cool. So you can see where is the North Star, which is this the north side? Yeah, this should be the north side of Uranus. And we might even be able to just put it up there. So all the planets have north stars, so to speak, some just brighter than others. So for this one, it looks like we're part of Ophiuchus. Yeah, Sabic. Nice. Which is actually pretty close to the ecliptic, I believe. So you could even possibly have some planets. If I bring up the ecliptic, as seen from Uranus. We have all these fun markings that you can put up in Stellarium. So if I just put up our ecliptic, there we go. Wait, I don't see it. I lost it. I missed it. All right, let's try that again. Put up the ecliptic. There's ecliptic. I'm seeing. There's an ecliptic. All right, yeah. So that ecliptic, like I said, it goes right by. I think that was Sabic. Did I get that right? No. Okay. So close. So it goes close to Sabic. So you'll have these planets kind of going through, and the sun at some point, as we saw earlier, going kind of close to the pole there. So that's kind of fun. So you have basically 40 years of light, 40 years of dark, and a year or so of twilight in between if you are at one of Uranus's poles. So kind of a fun thing if you want to take a trip and check that out in all your spare time. So cold, far away, lots of seasons. And I'm pretty sure there were some other exciting things I wanted to share. The storms, it does have seasonal storms. I pop back over to our open space. So it does have seasonal storms, but not a whole lot is known about those. So if you want to be a storm tracker for Uranus and go track some of those storms, that could be really helpful. And I would definitely be interested in finding out more about those. One of the other interesting things that I had read about Uranus in another lifetime was that the winds at the equator. So again, there's not like a solid surface that we could land on. So that's why we went back to Stellarium to get a closer look from the kind of ground-ish. But the winds at the equator are like retrograde. So I guess like the winds at the equator are going like the opposite direction that Uranus is spinning, but Uranus is also spinning retrograde. So it's like you have a retrograde. So the winds at the equator are kind of like prograde, I guess, for the solar system. And then, closer to the poles, they're prograde for Uranus, retrograde for the rest of the solar system, because I don't know. Sometimes thinking about a negative and a negative, making a positive, but my brain can't do math at all this late. So, so fun thing there, but also just the temperatures that even though the poles end up facing the sun for half of the year, which again is like 40 years on Uranus, you actually get warmer temperatures along the equator. So kind of an interesting thing. So, so we didn't actually flip through a whole year in open space, but maybe we can do that another time. I do want to revisit Uranus when when not so many interesting things are happening on Earth. But I'm just going to leave it there for now. So we're just going to say that was Uranus, just a little bit of Uranus. We'll do more Uranus, we'll do more moons, and really I want to do more stars and sparkly things in the upcoming weeks. Next week, actually, we have mission of the month. We'll be looking at a current mission, so that'll be a lot of fun. So if you're around, the world is still here next Thursday, tune in for another little tour around your celestial neighborhood, specifically to the asteroid belt. So looking forward to checking out some asteroids and comets and little bits and pieces of fluffiness a little closer to home. So I'm Irene Pease, I'm your friendly neighborhood astronomer. Thanks so much for joining me for this little stroll around our celestial neighborhood. I just want to say clear skies, be safe out there, and wear a mask.